Good afternoon everyone, I'm John Francis Evangelista from BZ1F and I'm here to discuss about linear momentum by yours truly, John Francis Evangelista. So first, let's determine what are our objectives. First, to define what is momentum. Second, to know the relationship between momentum, velocity, and mass. Third, to know the relationship between momentum and force. And fourth, to know the concepts in collisions. And lastly, to have the basic skills in computing simple problems regarding momentum. So first, let's define what is momentum. Momentum reflects the tendency of a moving object to continue moving and difficulty encountered in reducing that motion. So momentum is equal to mass multiplied by velocity. Therefore, we can said or conclude that the momentum is directly proportional to mass and directly proportional to velocity. So, the massive the object is, the greater the momentum. And the faster or how fast the object is means also that it has greater momentum. So we have the equation here: momentum is equal to mass times velocity. So second, what is the relationship between force and momentum? So according to our formula in the last slide, momentum is equal to mass times velocity. So if we divide this by time, both by time, so momentum divided by time is equal to mass times velocity over time. So as we all know in our subjects or in our past subjects or past lessons, v over t or velocity over time or the change in velocity over time is equal to acceleration. Therefore, momentum over time is equal to mass times acceleration. And we all know that the mass times acceleration is also equal to our F net or our net force. So therefore, we can conclude that the F net or net force is equal to the momentum over time. So that is the relationship. So next. So what is the law of conservation of momentum? It only stated that the momentum is conserved and it is equal. It is only transferred by the collisions or any other means, but it is always equal. So momentum 1 or the mass times velocity 1 is equal to mass to velocity 2, or the momentum 1 is equal to the momentum 2. So let's apply it. A force was applied to a 5 kilogram block. This is our first example. To speed it up from rest to 20 meter per second in 4 seconds. Our problem A is what is the change in momentum of the object, and B, what average force was exerted to the object. So our solutions is the momentum is equal to mass times the change in velocity. So our momentum here is equal to 5 kilogram our mass times 20 meter per second our velocity. So therefore, our momentum is 100 kilogram times meter per second. It is positive because according to our problem, it speeded up from rest. So final velocity 20 minus 0 is equal to positive 20. So therefore, let's continue to problem B. What average force was exerted on the object? So according to our derivation in the last slide, F net is equal to the momentum over time. So our momentum here is, we compute it here in A, 100 kilogram times meter per second divided by our time here, 4 seconds, it is equal to 25 Newton, and that is our net force. So let's continue. So this problem is it applies to conservation of momentum. A 1.6 kilogram ball whose velocity is 8 meter per second moving southward collides with a 2 kilogram ball traveling along the same path. So they are in the same path and southward, same direction, with a velocity of 5 meter per second southward also. If the velocity of a 2 kilogram ball is 7.29 meter per second southward after impact, what is the velocity of 1.60 kilogram ball? So according to our formula here, M1 V1 is equal to M2 V2. So 1.6 kilogram times the V1, it is unknown, is equal to 2 kilogram times 7.29 meter per second. So when we derive the formula, the velocity 1 is equal to 2 kilogram, or the M2 times V2, 7.29 meter per second, over the M1, or 1.60 kilogram. So our answer here is 9.11 meter per second. So that is our velocity 1. So therefore, let's check if it applies the conservation of momentum. M1 V1 is equal to M2 V2. So the momentum 1 is equal to 14.58 kilogram times meter per second. So our momentum 2 also, 2 kilogram times 7.29 is also the same. So 14.58 kilogram times meter per second. So it applies the law of conservation of momentum. And that is all, class. I hope you find the lesson interesting. Thank you very much for listening.